All my calculators are finally back. They told me. So we're going over chapter 6. Put it in your calc, and let's find the point estimate. See what the point estimate means. So I put it in my calc in my L1. I do a 1 var stat. Is this a population or is this a sample? Sample. A sample of how many? 30. This is a sample of 30. So I'm looking for my mean and my sample standard deviation. Although we don't need this because they give us a previous one. So I just want my mean. That's my point estimate. If you remember way back when we did little experiments with this, your population mean is the same as your sample mean. We found that your population mean was equal to your sample mean. So that's why we call this a point estimate. We don't know the population mean, so if we take the sample and we find that mean, that's what we're going to use to represent the population. So this guy just needs an X bar. I'm going to do these with the formulas, and I'm going to do them on the calculator. If you remember back, the confidence intervals are fantastic on your calculators. They look like hard problems, but the work is simple. So we're putting this into your L1. Does anybody come up with a mean? An average mean? 98 point. It should be 1, 1. Now, why did I go 2 decimal places?
That's what it was for the numbers up there.
We usually actually go 1 more, but why on this particular case do we go 2? Because it's money. Because I'm talking about money. These are the costs in dollars. Okay? So since I'm talking about money, we'll keep it 2 decimal places. Now, they gave us previous information. Your population standard deviation is this. Okay. So my n is greater than or equal to 30. That tells me z-score. And I know my population standard deviation, so that tells me I need to use my z-score. If I didn't know my population standard deviation, and I only knew my sample, what would I use? Z. So that's your deciding factor. Now, your margin of error formula. Your margin of error formula said, find me the z-score for your confidence interval, take your standard deviation, and divide it by the square root of n. I'll do these on the form, and you get the formulas with you too. I'll do these formulas and calculator. So this guy's the issue. How do I find this? So I'm looking for a 95% confidence interval. That means in here, this is 95% in the middle. Where else would I put my 95? I got to put it somewhere. I can't put it to the left. I can't put it to the right. I put it in the middle. So I'm looking for the positive and the negative, and the only one I need is the positive. So now, this is the tricky part. Inverse norm. Go inverse norm. Now, easy way. Do parentheses. 1 minus 0.95 divided by 2. I want to divide by 2 because it's sharing those 2 pieces on the end. So the 95 goes in the middle. When you find this, Keep it 0 and 1 and paste. 2 decimal places. Negative 0.196. But we said all we need is the positive. So my ZC is 1.96. Again, that 95% goes in the middle. Right? I have no place else to put it. Left or right? I don't know. So now, I'm going to plug this guy in here. I'm going to plug in my standard deviation. I'm going to divide it by 30, and this will give me my margin of error. Make your margin of error the same decimal place as your mean. And when I plug this in, what do you get? Good. Thank you. 8.05. Now I take this 8.05 and I say x plus or minus margin of error. And I got to write this out. So 98.11 plus or minus 8.05. Add it and subtract it. So you are going to get 98.11. No, sorry. 90.606 to God bless you, 106.16. This is your final answer. And how you interpret this guy is we say, I want to be 95% confident that my population repair costs for dishwashers for the population will fall between 90.06 and 106.16. I know my sample. I don't want to know where my sample is because I know my sample. I want an estimate for the entire population. Okay? Now, let's put this in your calculator. It's a test. So stat. Test. It's an interval. So I'm going to go down till I find my interval numbers. Here's all my intervals. What am I using? Z squared, T squared. Z. So I'm right there. Z interval. I am right at the Z interval. And when you do this, you could have put this in your data and just let your calculator fill in the rest. Or since we did it ourselves, we can put it here. You will still have to fill in your population standard deviation because your calculator doesn't know that. It can't take it off of this because you have a population. It will fill in this one for you, your mean, and far more exact than 2 decimal places. Your N, you've got to put this in. What level are you? And calculate. Now, if you remember back, how did we get our margin of error if we didn't use your margin of error formula? Yeah, we'll subtract the mean from the highest one. This will give me 8.05. There's my margin of error. So you can bypass finding Z to C. You can bypass using formulas. Use your calculator. If you use your calculator, give me your calculator stat. Because what happens if you use the wrong one, the T or the Z, and I don't see it, your answer obviously will be different. If your answer is wrong, then it's all wrong because there's nothing for me to go by. If your answer shows me that you use the T instead, so you lose a point out of whatever possible point you could lose instead of the whole thing. Remember these? They weren't that bad, right? Okay. Another one we did for this was finding a sample space. I'm going to give you these formulas, but you have to know when to use them. You want to estimate the mean repair cost for dishwashers. The estimate must be within $10 of the population. Box that up. Determine the required sample size. Box that up. For a 99% confidence interval for the population mean, and again, my population standard deviation is 22.50. So we want to be within this. And what is it we want to find? The N. Good. The sample size. So I look for a formula that says N. I look on my formula sheet. I'm still in my z-scores. I look for the formula that says n. And it says, take this, square it. This is my ZC times my population standard deviation over my margin of error, and then I square it. So my ZC, it's not a 95 anymore, it's a 99. So I'm going to do inverse norm, 1 minus 0.99 divided by 2. Because the 99 falls in the middle, not to one end or the other, because it didn't say, right? It doesn't say where to put it, so you got to put it in the middle. So I do my inverse norm, and this guy comes out to be 2575, or 2576, whatever you want to make it. So now I say n times my standard deviation divided by, oh, where's my margin of error? It's the 10, good, within. If I say within, that means less than, more than. If I say, I'll guess your age within 2 years, I can guess under 2 years, I can guess over 2 years. So that's where your margin of error comes from. I take this whole thing, and be careful how you put this in your calculator. My advice is that you use a fraction bar. For some of you get it, but don't put it in your calculator correctly. So this is equal to 33.568. So it's my answer. 34. Always, always round up. Because here's the problem. Even if this said 33.001, you're still going to have to round up. Because if you drop it down to 33, what happened to that 0.001 of a person? You didn't hit that one. So always round up on your population. Good with this? Okay. Kindly put the next one in your calc, please. So you're going to put it in your table. So the following data set represents the time in minutes for a random sample of phone calls made by employees at a company. Okay. Now, I'm asking for the sample mean and the sample standard deviation. There's no population standard deviation here. So if there's no population standard deviation and you have a sample standard deviation, are you using a Z or a T? T. And nicely, it said use a T. You're using a T because your population standard deviation is not known. So therefore, you're going to have to find an X bar, and you're going to have to find a sample standard deviation. Not a population standard deviation, a sample standard deviation when you do your L1. So you should find your sample mean to be 6.61. This time we're going to go one more decimal than our mean, because that's our rule. And we're going to find a sample standard deviation, not a population, of 3.38. They told us to assume your population is normally distributed, so we can use this. Right. We're going to do a 90% confidence interval. Now remember, this is for a T distribution. So I find my formula. I'll do it both ways. My formula is very much the same. A TC instead of a ZC. a sample standard deviation instead of a population standard deviation. Now the TC comes from your table 5. And table 5 is nice. Table 5 says find your level of confidence. Remember table 5? Look it up in the back of your book because you're going to have to do this. Look up your table of confidence, even if you have a table 5 handy. Find your level of confidence to be 0.90. Come down to degrees of freedom. So if I have n is 10, what's your degrees of freedom? 9. Find me your TC. You can. If you do it in your calculator, you're going to go to second VARS, inverse T, because this is your T. Same way. I want parentheses, 1 minus, what was our level of thing? 90. Divided by 2. Same way you do the other one. Degrees of freedom, 9, and paste. And you get a negative, but we want the positive. And your chart only gives you the positive numbers, but your calculator will give you the negative. So negative 1.833. Put your sample standard deviation in, divided by the square root of n, and this is your margin of error. I'm going to give you these formulas. Oops, 1.96, sorry. 1.96. Now, all you need to do is x bar. So I'm going to take my x bar plus or minus my margin of error. Okay. And you're going to give me, what is it, 4.65 to 8.57? This is what I want at the end. So let's pull up your calculator. I'm going through this, guys, but stop me if you have any questions. Again, these are great on the calculator. I'm looking for the word interval, and I'm looking for a T. There's my T. So again, put your information in. Your 6.61. Your sample standard deviation, you had to find 3.38. Your N was 10. Your confidence interval is 0.90. And you calculate. So there's your interval. And again, if you want to find your margin of error, just subtract your mean from the highest one. Calculator is great on these. I think if you remember back, I told you that's the one thing that I like, hypothesis testing and interval calculator. God bless you. Now, part D says, what if instead they did give us a population standard deviation? This was my population standard deviation. So therefore, I could really have used a Z interval. I'm going to do this on the calculator rather than the formulas. So instead now, I'm using a Z interval. My information stays the same here, and I want to get a 90% confidence interval. I want to see what happens. So I'm going to come here. I'm going to pull up my test. Oops. I'm going to do a Z interval. Same data. Here's my mean, 6.61. Here's my, oops, sorry. My population, what was it, 3.5. Here's my mean, 6.61. There's my N. There's everything else in here. And calculate. So here is my confidence interval. 4.79 to 8.43. Okay, so let's take a look at this. Let me find my margin of error. Minus 6.61. So my margin of error is 1.82. Make sense? All right. Which margin of error is larger? This margin of error or my z-score margin of error? The t. So which confidence interval should be wider? The t-score. The t-score says, well, you don't know your population standard deviation, and you're using your sample to assume what your sample standard deviation is. So I'm going to give you a little bit more wiggle room in here. So the t interval is always slightly wider than the z interval. It just gives you a little bit more leeway because you didn't know the population standard deviation. If your sample is not a good representation, then your intervals will be kind of skewed. But this gives you a little bit more leeway. We're only dealing with 10 in the sample, so it doesn't make that much of an impact. But you should see a difference. Make sense? No questions. We're just kind of in automatic mode here. Got it? All right. Okay, I'm going to skip number 22 because that's the same as this thing, basically. You can do 22 and then ask me tomorrow. I'm going to go down to the proportion one because the proportion works slightly different. Okay. In a survey of 1,037 adults from the U.S., are there more than that in the U.S.? Yep, easily. So this is my sample. N equals 643 out of those 1037 were concerned about getting the float. Excuse me. Find a point estimate for the population proportion of those who were concerned about getting the float. This guy is my X. How do I make a point estimate for my population proportion? Part over whole. Thank you. We call it p hat because this represents my sample. And X over N. Haranday said part over whole. That's all you have to remember. Excuse me. And divide it out, and you will get 0.62. This is my p hat. Okay. What is my q hat? The difference from 1. So 0.38. Okay. Now, I want to construct a 90-degree confidence interval for the population proportion. So I look at my sheet of formulas, and I look for my population one with the p hats in it, and I pull out the one that has a p hat in it, because that's what I'm dealing with. So I have this. I write my formula down just as I read it, and all I have to do is plug this in. But I need a ZC. How do I find my ZC? Inverse norm, good. Inverse norm, second pairs, whoops. Inverse norm, I'm z-score again. Doesn't this tell me z-score? Z-score again. I'm parentheses because it's the 90 in the middle, not to one end or the other. Divided by 2. I need to know those little guys on the end. And if you have, I will give you table 4. If you remember on table 4, the basic ones for z-score are on the bottom. There's a 90, a 95, a 99, and I think an 80. There's like 4 of them down there. So you don't even have to do inverse norm. Take it off of your table. So it's 1.645. Let's plug this in. And I just plug in my information. P hat is 60.62. Q hat 0.38 divided by how many in my sample? 1,037. Some of you are getting the n wrong. The n is from your sample size. So you plug this in, and it should be small, right? Because it's a decimal, it's a proportion. 0.025 or 0.03 if you want to round. And just take this guy, again, x bar, or sorry, p hat, plus or minus e. So p hat, 0.62, we can do plus or minus 0.03. So you're going to subtract this, 0.59, and you're going to add it. Now your calculator also has a one for this. Second, just plain old stat. Test, go down to the interval words. Now you're not a Z, you're not a T, you're not two samples, you're a proportion. There's my word proportion. There's my 1. I'm at the A. It's asking for your X value. So you just have to type in 643. It's asking, It's asking for your N value, 1,037. It says, what confidence interval do I want? 0.90. Well, give me my interval. There's my interval. 0.60 to 0.64. Your calculator rounds a little bit better than us because we had to find a p-hat. And there's my p-hat. See my p-hat? There's your p-hat there. Okay? Now, again, you can use your calculator for this. Just give me your calculator step. Oh, I know what I was going to say. Your calculator needs your x equals. So what happens if I have a problem and I don't have an x equals? What happens if I have a problem and I just have a p? And they said the percentage of this is, the percentage of my sample is 42%. I can use my formula, that works out well, but how do I put this in my calculator for an x? My calculator can't take 0.42%. It can only take an x and an n. So you take 42% of this. Just reverse your process. Before we said this was x over n. So watch, if I cross multiply this, isn't it p times n equals x? Don't I just cross multiply it? So take this times this. And the thing is, no decimals. You have to round to a whole number. That will give you your x. And if there is rounding, make sure you tell me what your x you rounded to, because that will make a difference in your confidence interval. Good? Okay. Alrighty. And last, well no, not last, but second to last here. Find the minimum sample size needed to estimate the population proportion. Minimum sample size. Uh-oh, I need a sample size. I need an n equals. And I have something that has a proportion. I have to have something with an n that has a p-hat in it. So I look at my formula sheet, and I do. It has a p-hat, q-hat, ZC. It almost looks like my other one, but I have to have a p-hat and a q-hat here. Okay, I'm still at the 99% confidence. Oh, I'm at the 99 now, so I'm going to have to change that. And where is my margin of error? Within 4%. How do I write 4% in a decimal? 0.04. Makes a big difference, guys. So my p-hat and q-hat, I think we're using the same one with 0.62. 0.38. We just changed to ZC. So your ZC is 2.575, because if we do inverse norm, we'll get 2.575 divided by 0.04 squared. Now put that in your calculator exactly the way you read that, with parentheses. And your n will be 976.36. So what's my final answer? 977. Good. Good. Do you have this question underneath this? What's your next question? What's your exercise?
Yeah, but it's on the other page.
It's on a different page, okay. But I don't know where this came from. Alright. We have one more to do. This is your chi-square. Okay, this should be my 24. It should be the 24. This one had a little bit of different things, and this uses table 6. So you're going to use chi-square when you're talking about variance and you're talking about standard deviation. There's no calculator set for this. But you have both of the formulas for this. So your formula for this looks like this. A left and a right. Those are the critical values you have to find. Remember your chi-square, and we try not to think about it too much, goes like this, and it goes from 0 to infinity. Doesn't have any negatives, and it's the opposite. Area to the right, but we're not going to worry about that. So we're going back to your question 19, and we're doing your n was 30. So the degrees of freedom are 29. And we're looking up a 95% confidence interval. So if I look up a 95 confidence interval, I have to do 1 minus this guy. And I have to do 0.05 and 0.95. Okay? 0.05 and, no, divide by 2. Divide by 2, 0.025, 0.975. I don't have the table in front of me. So if you go to table 6, you're going to get those two values, remember? And the smaller one goes on the left, that's the left one. The larger one goes on the right of our graph. This would be where your x2L is. This is where your x2R is. There's no calculator thing for this. There's not even an inverse thing for this. So you have to go to table 6. Look at table 6. I'll tell you the right information. It's in the back of your book. I just need you to be familiar with this because you might even see a 2-point question on this. So go to the back of the book to page A19. It's not that bad. So just remember, we're going to do it the same way we did your inverse norm. 1 minus the thing divided by 2. There's 2 columns. The table is symmetric. It just has degrees of freedom and it has your points across the top. Please look at A19. This is important. I do it this way so that you keep consistency. This we use whether we do inverse P, inverse norm, whether we do chi-square. So we do this, we find your 2 columns, and then see which one is the smaller one. The smaller one is the left. So this is 16.047, and the larger one goes here. The rest you can fill in. This is 29. Your standard deviation was I don't know if you did 19. Why am I having a hard time with these numbers? Your sample standard deviation is, I don't know. So your sample standard deviation, I'll give it to you. Your sample standard deviation is 24.722. So you're just going to plug this in here, and you have your whole thing set up. Just watch order of operations. If you multiply by this and divide, you're good. If it's a standard deviation, remember to square it. If it's a variance, don't square it, because it's already been squared. So when you get down to this, you get this. Now, to get from here to here, what do we have to do? Take the square root of everybody. So this guy becomes your standard deviation. And this becomes okay. You may see a question finding, the special values for your chi-square. So you're going to have to know how to do this, and you're going to have to know how to look it up on your table 6. Table 6 is just very basic. It just has one line across the top, one line down the side. Degrees of freedom, and those values across the top. If you look at those values, like 0.025, if you just took your 0.95 and subtracted it from 1, when would you ever get a 0.025? You wouldn't. So you have to remember to do this too. My advice is, look